Okay, so the homework questions, we left off at this, where we have to find the total volume for this diagram. So it's made up of a pyramid at the bottom. That is the only new part. So volume will be wanted base area times the perpendicular height, which we are easily able to find out by taking 52 minus 16. 16 is the perpendicular height for the base area of that prism. So take it away, we get 52 minus 16, 36. Yeah, 36 will be the perpendicular height for this pyramid. Okay, then the surface area of the base area of the prism is not a problem. Just multiply by the perpendicular distance for that prism, which in this case will be 25 cm. So that volume shouldn't be an issue for you, 7,000 cubic centimeters. Okay, then we had our textbook questions, but before that, let's move on to the last question in our notes first. This is an actual O-level question in 2010. So let's take a look at what an O-level question might look like for this topic. So we have a traffic bollard consisting of a pyramid. So pyramid on top, and there's a cuboid at the bottom. The base of this cuboid, together with this base of the pyramid, they are both squares, side 10 centimeters. So we understand what's happening over here first. Then they continue to tell us that the vertical height, Vn, is 12. And all the other dimensions given, 30 cm for that height of that cuboid. So first calculate the volume of the bollard. Okay, so Aloysius, how will you go about doing this? Volume of this bollard. Is that what you're right? Just start off with 1/3 times base area times height. Area of pyramid. Area. Confirm area. Volume. Okay, volume of pyramid. And what would that give us? Times 10 square times 12. Okay, so this is the volume of the pyramid. Get a value, so it'll be 400. Is it in centimeters? Okay. And what do you do next? Area again. A volume of the cuboid. Okay, so this is what he should be getting. Okay, 3,400 cubic centimeters. Okay, let's resume. Next, part 2. Surface area of the bollard now. They also tell you don't include the area of the bottom of the bollard. Okay, so in this case, let's identify how many surfaces are there for this bollard first that we need to account for. We've got our 4 sides for that cuboid. We've got 1 in front, side, the back, that's 3, and 1 more rectangle at the side. So total 4 sides. And these 4 rectangles are the same. Very easily you can find that out. 4 times 10 times 30. Next, we still need the areas of the triangle. So we've got 1, 2, 3, and 4 triangles as well. And conveniently, they are the same triangles. So I just need an area for 1 triangle. Okay, so let's just call somebody else to do this. Harry, okay, Harry. How do we get an area for 1 of these triangles? Slant height. Okay, which triangle would you like us to use? There are 4 of them. VBC. Okay, for some reason he wants to go to the side instead of the one in front. Doesn't matter. So let's draw it out. VBC. You wanted the slant height, right? Okay, so where would that slant height be? Okay. This is what he means. Yes. Okay, so how do we find this distance? X. Very good. So he decided to call the foot of the perpendicular X. Okay, yes. Let's identify the x over here, right? In the same original diagram. Okay, then what do we do next? Okay, so this is the key, Vx, which is what we require to find the area of this triangle. This Vx is actually the hypotenuse of V and X. When he says hypotenuse, he is implying that there is a right angle triangle that is formed. Okay, so we have now created another right angle triangle, which I'll just draw over here. V and X. Your goal is to find Vx corresponding to this hypotenuse. Okay, how? So I'm just going to put in the other values, 12. What about Nx? What is Nx? 10 divided by 2, because we have AB to be 10 cm. So since it is a square, 10 divided by 2 will give us the value of Nx, which gives us simply 5. 5 and 12, what do you think the hypotenuse is going to be? Okay, so how do we carry on? (12 square plus 5 square). And by now, we should be very familiar. This gives us simply 13. Okay, so we have now the perpendicular height for Vx. I mean, perpendicular height for that triangle, the distance is Vx, 13 cm. So if a BC value of 10, I can easily find the area of this triangle, multiply it by 4, and add everything up. So this is what we have. So I call the midpoint M. He called it X. Doesn't matter. So this is what he mentioned, 13. Then total area, 1460. So clearly, we do not include the area of the squares at the top and the bottom of the cuboid because they are both concealed. So if somebody has to paint this bollard, it will be the 4 rectangular surfaces plus the 4 triangles. All right, then after this, we're moving on to our textbook questions, exercise 10.1. If you're done with this, please take out your 10.1. So you finished? Oh, hey, Harry, do you choose this triangle VBC because you want to be able to draw this triangle easily? Oh, okay. Very good. If like I said, if you all want to choose VAB as your triangle, also can. But then to find this slant height, let me show you. You're gonna find this slant height, right? Let's call it Y. To find this slant height, you will then need to draw this triangle, which is a little harder to see. That triangle has the same dimensions as what we originally created, N, Y, and V. So this will be 12, this will be 5 as well. It's the same. Okay, it's just it might be a little harder to visualize this particular triangle. Okay, so now our textbook questions, what do we have? 5, 7, 8, 14. Okay, 5 is a basic question, slant height. Just check answers. Need help, let me know. I don't think you need help for this. We have already done more advanced questions. So B, draw the net, find total surface area. The net is made of a square plus 4 triangles. Okay, as such. So notice that for the net, include the dimensions if you have them. And then the total area, no kick. I'll just show you the final answer, 896. Anybody needs help? Arisha, okay? Omera? Any issues? Okay, 5, done. Next question is 7. All right, right pyramid, rectangular base. So 22 and 18, that's a rectangle for this base. Find volume. Wanted base area times height. That is the formula you need to memorize. Wanted base area times height gives us 3036. Okay, I'll just carry on. If you need me, must stop me. Others, I'll just keep going on. Total surface area. Now, in this case, similar to our question in our notes, we need to find the slant height for each of the triangles. So we can see the distance and to this number 18, that is a total of 11. So Pythagoras theorem to find the slant height for the triangle VXY. And we do the rest. Wow, so long. Okay, so area 1400. Anybody needs help? Is that okay? That's question 7. Next will be question 8. Okay, this time they don't draw the dotted lines for you for that triangle. Find the total surface area. So area of the 4 triangles plus area of the rectangle at the bottom. Area of the 4 triangles depends on the slant height for the triangles. Okay, I'll just show you the answer first. Let me know if you need help. Oh, so long. 1590. Anybody needs help? Ishan, okay? Yeah, correct. You need help? Zixuan. Sorry, Ishan is not here. I was thinking of Ishan. What happened to Ishan? Quarantine. Okay, never mind. I'll check with Misty. Okay, next one. Part B, volume of the pyramid 3500. Daniel, okay? For part B? Why is this so? Because they literally do every single step. When in reality we actually skip some steps. Have you seen what you wanted to see? You don't know what you're looking for? Must it be 3 significant figures? Yes, because there is a square root 407. Why? What did you have an exact answer? Then what do you leave it as? Why? I'm sure it's gonna be 3 singular figures because that we end up having a distance that is not exact, which should be the case for you as well. Yes. Okay, so this is question, what is this, 8? Okay, question 8 done. Then 14. Find the length of a side of a square base of the pyramid. 20. Anybody needs help? Yes, okay, I expect that. Okay, so we have a solid metal rectangular pyramid. So rectangle at the bottom, they didn't say it's a square. The base measures 16 by 25. They don't tell you the height. So it could be any height. But they carry on to tell us the solid is melted. Melt it, recast into a solid square pyramid, same height. So find the length of the side of the square base of the pyramid. So we know now that there appears to be 2 unknowns. The length of the square, as well as that common height. Let's call the side y, we can call it x, y, whatever you want, and h will be our common height. So now we can form an equation. What will the equation look like? What did they say is equal? Equations are left-hand side equal to right-hand side. Is there something that they tell us is equal? Zheng Jie, is there something that's equal in this question? Nothing equal. Louder, louder. The square is equal. What do you mean? The heights are equal. Yes. Jermaine, can you tell me another thing that is equal besides the height? In this question, there are two things that are equal. So Zheng Jie gave the height that is equal already. Something else that is equal. The side. Side of what? The side of the square. Hey, that one, of course, square has the same side. Give me something else. I want you to picture this. A pyramid melted down, metal pyramid melted down. You get a tub of liquid. Then you recast it into a right pyramid. Something didn't change. What didn't change? The volume, yes. The volume didn't change. That is how we start off with the equation. So 1/3 base area, in this case, y squared for the new pyramid times the height equals to 1/3 base area of the rectangle, 16 times 25 times the height. So Zheng Jie said that the heights are the same. What will you do with these two values of h, Zheng Jie? What will you do with the two values of h? How? Hey, you are right, get rid of them, but how to get rid of them? Exactly, you know it. Divide by h. And we will simplify to get y squared equal to 400. Y will be positive value of square root 400, which is 20. Okay, we reject the negative one. We don't even bother writing it because we're dealing with length already. And that brings us to the end of the chapter 10, part 1 of the notes. That doesn't look like maths. Yeah. You talking about the maths in physics, is it? Yes, student tell me yes. Okay, next one. We're going to move on to chapter 10, part 2 of the notes.